All right, you radio diehard repairman, this video is for you. This is the video that when you have a problem, somebody actually comes along and shows you what's going on. And you're like, holy cow. Now, the first thing I'm going to show you is hum modulation on this radio. And I'm going to explain hum modulation. Then I'm going to tell you what was really wrong with this radio. Wasn't my fault. Again, this has happened to me. I'll explain it all to you. But first of all, we're going to plug in. We have the filaments warming up. I have to reach across and plug in the B plus power supply. All right. Now you hear that hum? All right. I'm going to talk after I disconnect. Right now, I'm going to disconnect the antenna. Notice the hum's gone. Not the power supply, is it? Now, what's happening is the oscillator of this radio is leaking out of the radio and maybe other frequencies, intermediate frequencies. And because the radio has the shields off, it's out of a metal box. So that's the only way you can really align it and troubleshoot it. But it makes it really hard because the hum modulation on this radio is really bad. This thing's like really bad, poorly designed. But they must have done it in a certain way. But I'm going to show you what I actually found. This is what I do. Remember, I don't just put a bow tie on, sit in a chair with a whole bunch of test equipment behind you. I actually dive into these radios. And when I find something that screwed me over or made me crazy, I'm going to show you. And hopefully it's the secret that gets you to the next step. All right, we're going to put the antenna back on the radio and the hum will come back. All right, now we have the radio. It's on manual volume control, so it's going to be a little bit garbly because it's being overloaded. Hard to believe, huh? All right, we're going to put the ground lead on. Oh, we're going to put a ground lead on the chassis of this radio. Ready? All right, now there's the station. Now I'm only coming out of the headphone jack into a transformer to a speaker. So I don't have a lot of output. But it sounds a little garbled. That's because it's in the automatic, the manual volume position. We'll go to automatic volume control. All right, there we go. That's manual. See, it's louder, but it's garbled. Automatic volume, very clear. All right, so let me turn the volume down on this. So how did I learn about hum modulation? I was building this transmitter in an online group, which was a mistake, because as I did the schematic, another guy kept redrawing it. I won't tell you who he was, but he's nuts. So anyway, I mentioned no matter when I build an AM transmitter, I get hum, like the power supply. And it's always been there. And if I run the transmitter on battery, it's not there. So some guy from the UK, he puts in there, look into hum modulation. That's all I actually need. You know, well, what do you mean? No, he said, look into hum modulation. So you go to Google, hum modulation, and all of a sudden it tells you about the frequency leaving the transmitter, going out, going on the wiring, and coming back into the power supply and getting into the transmitter. So it goes around in a circle. It's almost like regeneration. So how you fix it is in the power supply, you put some capacitors from the AC to the chassis. Now in this case, I added a ground to the chassis rather than touch my BC 348 power supply. I showed you how to make these, what transformers to order, and the whole thing on a previous video. Did that? No one else did it. One other guy got the idea of copying. He went in his junk box and whipped up a supply real quick. No finesse to it at all. I'm going to make fun of these guys because when I didn't do good in school, these guys made fun of me. Now, second part of this video. Why was I having so much trouble getting WEEU? All right, here's the secret. Originally, I discovered there was a wrong resistor on the mixer, and that sort of made it a little bit better. Adding a little bit more voltage at this power supply gave me more sensitivity. And I kept reading and reading. All of a sudden, I noticed these resistors in here didn't match my schematic. So I start digging, and the more older schematics I found, these values change. All right, off the B plus line in the radio goes to a 1K resistor. That 1K resistor feeds, for these two tubes, that 1K resistor feeds a 40K resistor, which then goes down to a 75K resistor, which goes to ground. And the source resistor is 1K, goes to the top resistor, which is called a feeder or a divider, and then that goes to the bleeder resistor. The bleeder needs to be 75K. In my radio, it was 39K. So the screen grid of the two RF amps were running at 28 volts. Now, a screen grid, what it does is it's next to the plate of the tube, and you make it positively charged a certain percentage of the plate. 28 volts wasn't enough, so they made a change to make it 90 volts. Big difference, right? Well, this radio either had a different plate on it and they switched the plate, or this was a very early model. So my two RF tubes, no matter how I took the voltage readings, were normal. Resistance were reading. That's because that page that's got the tube sockets and it tells you what voltage, that's old. No one ever updated it to match the schematic that they now use. So if you're working on one of these and you have the schematic I told you from, I think it was 1946, 45, that's the newer schematic. You'll find a 1K, a 40K, and a 75K. And also, in the schematic, it'll say 75M and 40M. That's wrong. It's not. They're not megohms. They're K. And that's another mistake I found. See, I got this radio working, and I told you that. Got it working, recapped it, but it wasn't working the way I should have get. I want to get WEU. That's my test station here. And it would just barely get it. And it is at the top of the dial for this wackadoodle radio. It's got two bands. So that's going to make it a little less sensitive. So, but I did stay with it. And now I've now found out that changing these resistors, I had some wacky problems down in the IF of this radio is 92.5 kilohertz, not 455, not 470, 92.5 kilohertz, not megahertz, kilohertz. This radio is a wackadoodle. But at some point, I'm laying in bed, I'm going, that radio has to work better. I bought it because it's got a dual front RFs, and they're both on. The signal comes in from the antenna, and it goes through this adjuster box, or it's an adjuster capacitor. It tunes it up. Now, that only really works good when the radio is grounded. Found that out today. See, what I do is when I find something out, I tell you, I don't sit with a bow tie, with a background of old radios and stuff stacked, and talk about the specs of the radio. I go into it, and I know I spent a lot of time on this radio, but that's because it needed it. And somewhere there's a person that'll watch this and it'll help them. That's what I'm all about. I don't want to brag to you. Look what radio I just bought. Oh, I got this. It's in mint condition. It's new old stock, and I hold it up and things never seen any power for 80 years. Well, trust me, this thing has seen power. This has seen soldering irons. This has seen solder suckers. This has had tubes swapped in and out of it. But this tube, they don't call it a tube rack. Tube shelf. They call this a tube shelf right here. And for me to remember all these words, because the military, let's call it a tube assembly. No, let's call it a tube shelf. Make it harder for the guys that work on it. What about this model? Oh, that's one of the old ones. Just slap a newer plate on. We'll send it out. They'll catch it. They'll catch it out in the field and flag it as not working good. See, but there's probably more that is wrong with this radio as far as it not being updated. I did look for older schematics, and I did find it. Like that, I said, the one page. It tells you to take the resistive reading to ground and the voltage, and it said, I think I said 28 volts. It's supposed to be 90. The new BC314D should have 90 volts on the screen grids of the first tubes. Okay, I hope you learned something from it. And the HUM modulation, just ground the chassis. Be careful now. But in other words, that's it. There's hum from a power supply when you got a bad capacitor or not enough capacitor, or the whole thing's just poorly designed. And then you got your signals from your radio go out through the air, they get on the line cord, and they come back into the line cord. They get reamplified by something, and it's like regenerative. And the hum becomes really annoyingly loud. Now, let me put the volume up. And like I told you, I'm using the headphone output. That's why it's not that loud. There is another amplifier. That's next step, to run this nice clean audio into the final output, which has a jack on it, which I'm going to change. I'm not keeping this absolutely original. But we turn the volume up. We remove the ground. Oh yeah, that's what I've been listening to. And if you go on either side of the signal, you got to go up to a dial. Listen, I'm going up through the dial. Isn't that fun? Trying to make the radio work better. All right, let's put the ground on.
Their police activity continues. Bridges are pretty good. Some are very down. We're looking at jams.
Oh, this antenna tuner. That's what I'm tuning right now. That works when you have a ground on the radio. It doesn't do anything without the ground. That drove me nuts. Okay, I think that's it now. All right, that's it. Hope you learned something.
Fine, and look at the forecast.